Now that we have covered abstract classes, let's talk about Java interfaces. Now, an interface is another way of achieving abstraction. So it's in some sense kind of a full abstract class. So classes do not inherit or do not extend interfaces. They implement interfaces. So you cannot use the keyword extend to inherit the interface. You will use the keyword implements. Now, the advantage is you will be able to force method implementation or forcing standard while supporting multiple implementations. So a class can implement interfaces with or without extending another class as well. Now, if you recall, Java will not support multiple inheritance. So in Java, you can only inherit one class. If you want to achieve something that's close to multiple inheritance, then you will have to implement a class that's implementing another class that's inherit a class that's inheriting another class that's inheriting another class, and so on. As for interfaces, you can have a class that implements as many interfaces as you need. Now in UML, we will use the keyword interface to say that this is an interface. And I will talk about this in a minute. Why is it all in caps? And in Java, we will say interface and then interface name followed by curly brackets including the interface body. Now, how do we say that a class is implementing an interface? We will have a triangle and then a dotted line between the class and the interface in UML. Now, couple notes about interfaces. I just said I want to talk about the voltage that was all in uppercase letters. This signals for a constant, and all values provided by interfaces are going to be public constants. All methods in an interface are abstract, so you cannot have or provide any implementation for a method in an interface. A class implementing an interface will have access to the values it provides. So if you're implementing any interface, you will be able to access the public constants that you have in that interface. A class implementing an interface must provide implementation for its methods. Again, because all of the methods are going to be abstract by default, then you will have to provide implementation, which is what we meant by forcing standards. A class may implement multiple interfaces, so you can implement any number of interfaces, but this is an advantage over inheritance, which is going to allow you to only inherit one class. So if we have interfaces and we can implement interfaces, why do we need abstract classes then? Let's see. Now, abstract classes will enforce standards. So when do we use abstract class and when do you use interfaces? Both of them enforce standards. Now, if we want to prevent class object instantiation, we will create an abstract class. And one of the advantages of an abstract class that cannot be achieved with interfaces is that you can have abstract methods and you can also have fully implemented methods for the classes that's going to extend your abstract class. Now, when to use an abstract method? If you want to force the subclass to provide a unique implementation for that method. So I don't want some kind of general implementation that any class can use. I want this method to be implemented by every subclass, and they should have their own implementation. If that's the case, then you make the method abstract. Now, when to use an interface? To specify some behavior of instances, or if you want to support multiple implementations. Now, let's see an example of interfaces which is going to make everything clear. Now, let's suppose that we have what we call an electric car. Now, a convention for interfaces is having the name with the able uh, key thing on it. So for example, if the interface is for charging, then we'll say chargeable. If it's for let's say expanding, I don't know, we'll say expandable. So everything is going to be able after that. It's not a must, but it's just kind of the convention. So we will go right click and then new interface. And for my interface, I want to call this chargeable. And let me finish this. Now this is my interface, public interface chargeable. Now again, as we said, every value that we provide is going to be a public constant. So I will go integer voltage is equal to 110. And now this is going to be available for every class that's implementing this interface. Now what I'm trying to achieve is, if I have some electric car, then that car needs to be chargeable. And for a car to be chargeable, then I need that car to give me an implementation for how this car is going to charge the battery, let's say. So public void charge. That's it. And then public void, let me say something like show range, which is the range of the car that's remaining on the charge. Oh, this needs to be this. And now let me create an electric car. So electric car, and this is going to be my class. Now I can implement an interface with or without extending a class, but since an electric car is nothing but a car, so I'll just do extends car, and let me have a constructor here, and let me just say an integer range. Now these methods can be void, can be integers, can be any return type, but I'm making them void just for simplicity, just to make everything simple and easier to understand. Now whenever I create an electric car, I will just set the range manually to something like 30, which is a bad electric car that's going to get you 30 miles. And then in here, now everything is working just fine. I don't have any issues with this, but I need to implement chargeable. Now the moment I save it, it's going to ask me to add those methods. Add unimplemented methods, charge and show range. So I can double click this. Again, this override is not necessarily, you can leave it, you can take it out. I just like to take it out. And then you can do anything in here. So what I will do is, whenever I charge, range is equal to 30 again. And show range, system.out.println, the range is, and then plus range. Now if you recall, in my car class I had a drive method. So what I can do is I can use it, or I can just say public void, and I'll just override this drive, and I will just use the implementation in the superclass and add something to it. What I'm gonna add is I will just decrease the range. So range minus equals 15. So I'll just take 15 miles every time I drive. And then we can do something like an if statement, which is going to be even better. So if range is less than 15, or this should be larger than 14, larger than or equal to 15. We will do this, else system.out.println, something like you must recharge the car. Now what I can do is I can come back to my driver and I can say electric car AC is equal to new electric car, and then I will say this is a Tesla, and I don't know much about them, so sport, I don't know if that's even a thing, and then 2020. Okay, now let's do this. AC dot drive, AC dot drive again, AC dot drive one more time. Let's see if our method works. So we were able to drive the first time, we were able to drive the second time, and then we cannot drive. Why is that? Let's show the range every time before that. Let's just play with what we just did. EC.show range, and then we'll drive. EC.show range, and then we drive. EC.show range, and then we'll try to drive. And now, first time range is 30, we were able to drive. Next time is 15, we were able to drive, and then it's 0. We must recharge. Now let's do this. EC.charge, and then EC.show range and EC.drive. We must recharge, and then we did a recharge, and then we did this. I mean, we can just go here and say whenever we recharge, we can print a method, and print something that this method worked. So the vehicle is fully charged. Now we can run this. Now again, we were implementing one class. Now I can do something like this. I can go ahead and create another interface, and I can implement multiple interfaces. So raceable, a car that's raceable, for example. And I can let me just do something like public void race. And then my electric car, let me make it erasable. So it's already chargeable, and I want to make it erasable. What I need to do is I just have a comma here and say erasable. Now I'm implementing chargeable and erasable, but then I got an error here because I need to implement this method. And this tells me whatever interface I implement, I need to provide a unique implementation for that method. And then I can provide any implementation here as I would like. So it can be something like close to the drive, something that's not even like it. You can just provide any implementation. Now, just to recap, you can have some kind of standards enforced by interfaces, and you can have standards enforced by abstract classes. The main difference between those is an abstract class. So abstract class is a class, and you can provide instance variables. You can provide full implementation for any method that you want. You can have unimplemented methods. You can have fully implemented methods. That's in an abstract class. Now for an interface, you cannot have instance variables. You can have values that are going to be provided as final and public. So it's basically not just variables, it's constants. So you'll provide constants, and any class that's implementing that interface can have access to that constant. Any method that you are going to have in your interface is going to be an abstract method, and you can implement multiple interfaces by separating them with a comma in here. Now you can have a class that's extending another class, and you can have a class that's not even extending another class. Now I can delete this, and it's going to still work if I just edit the code here and get rid of anything that I'm inheriting from the car class. And you can again, so let me just show you a quick example on that. I don't know, just a class that's going to implement chargeable and raceable. And then if I save this, I just add the implementation for those methods in those interfaces, and I don't have to inherit any class. So you can have inheritance on its own, you can have implementation of interfaces on its own as well.